In this chapter, we are talking about mathematical calculations, so we have to talk about units that are derived, which means that they're going to be a combination of the SI metric system units that we've seen. You already know ones for area and volume from math class. We're going to definitely talk about density in this chapter and for the rest of the year. In the next chapter, we're going to talk about molar mass, where we talk about grams per mole, molar volume, where we talk about liters per mole. When we get to energy, we're going to talk about joules and calories and joules per gram degree Celsius. So you're going to see that all of these are going to have a combination of our base units that we use for the International System of Units. Okay, so just to review, volume is the amount of space occupied by an object. So that is going to be your three-dimensional space. In math class, you probably did volume equals length times width times height, or of an object, base times width times height, for like the length of that. Volume will be measured in meters cubed, centimeters cubed, milliliters, or liters. Sometimes in like doctor shows, you'll see that they say, give me like 10 cc's of something. Well, cc stands for centimeter cubed, all right, cc, cubic centimeters. But basically, a cc is the same thing as a milliliter, okay, in water. That is the case. So 1 cubic centimeter is 1 milliliter. 1,000 milliliters is a liter, like we went over in the metric prefix video earlier in this playlist. Mill, milli is going to be 1,000th of a liter. So that means that if we have 1,000 of them, it'll make up our 1 liter. All right, the other super important derived unit that we are going to use for the rest of the school year is density. Okay, density is a ratio of mass to volume. Get used to loving density. Okay, density is mass over volume, M over V. I always say get used to that because if you take a look, the M and the V, what happens? It makes a heart. So that is why we love it, mass over volume. Okay? You can even put your hands together in the good Taylor Swift way. Um, Grams per milliliter are usually the units that we use, or if the volume is actually measured, then you would see grams per cubic centimeter, but they are the exact same thing because remember, 1 milliliter is the same as 1 cubic centimeter as well. All right, so with density, density is going to be a very cool physical property, touching back on the last chapter as well, where you can identify different substances, and if they're not miscible, if they don't dissolve in one another, you see that they can layer upon one another. So oil and water don't mix. Oil is less dense than water, so it is going to float, where golden syrup, which is going to be the same thing like corn syrup, is going to be more dense than water, so it is going to sink. All right, and water is typically known as having the density of 1 gram per centimeter cubed. This is at 25 degrees Celsius, which is room temperature. The density of water changes with temperature. But for the most part, we're dealing with things around room temperature, so it's going to be used as one. So things that are less dense, like corks and ice, grams per centimeter cubed, ice will float in water. Gasoline, alcohol, ethanol will all float in water. But the things that are more dense than water will sink. So bones will sink in water, lead will sink in water, mercury will sink in water. Okay, most solids will sink in water. There's some that aren't. more dense, but most will. Okay. So what we need to be really comfortable with is solving for this density equation. So please go grab your calculators. Really important that you try these and just don't watch me put it in the calculator. All right, so if you have a sample of aluminum metal, it has a mass of 8.4 grams, and the volume of that sample is 3.1 cubic centimeters. Calculate the density. So I am given that I have a mass of 8.40 grams. My volume is 3.1 centimeters cubed. My unknown is going to be my density. So what is the conversion factor or the equation that I use? Density is mass over volume. Now what do? I plug in my values. All right, so I put my 8.40 grams on top. I take my 3.1 centimeters cubed on the bottom. I plug it into my calculator and I get 2.7 grams per centimeters cubed. Now, did we round to the correct number of sig figs? This has 1, 2, 3. This one has 1, 2. So 2 wins. Yes, 2.7 wins. And you can verify this information on the periodic table to see what the actual density of your aluminum would be. So again, you have your mass given, you have your volume given, you're solving for density. You simply plug in the calculator 8.40 divided by 3.1 equals, and you get your 2.70. Since none of these units canceled out, you use the units of grams per centimeters cubed. Okay, so let's take a look at a second example for density. All right, in this problem, we see that a sample of aluminum metal has a mass of 13.8 grams, and we know that the density of the sample is 2.70 grams per centimeters cubed. What's the volume going to be? So now my given is a mass, again, of 13.8 grams. Density is given 2.70 grams per centimeters cubed. How do I solve for volume? Okay, so my parent equation, what I use is still that D equals M over V. And one of the problems that historically happens with everybody is they freak out when they have to solve for a denominator. Well, you have to isolate that variable. So what do? You want to get that variable up on the top. So let's multiply by V on both sides, and then let's divide by D on both sides. So density and density cancels out. Volume and volume cancels out. We get volume equals mass over density. So if we really take a look, if we're starting with density equals mass over volume, and we end up with volume equals mass over density, what you really can know if you have some number equal to a ratio of things, basically the D and the V switch spots. Okay, so once you get that trick under your belt, solving for a denominator is really good. And that's something that my seventh grade teacher, Mr. Fleck, taught me. And I really found that that saved me a lot of time and aggravation as I got older. Okay, so if we solve for this, okay, volume is mass over density. We put 13.8 grams on top, 2.70 grams per centimeters cubed on the bottom. What happens here is grams and grams cancel out. So we end up getting inverse cubic centimeters. So what's the inverse of the inverse? It's the inverse, or just centimeters cubed. It's just that number. And when you plug that into the calculator, all right, 13.8 divided by 2.70, what you end up getting is 5.11111. So how many sig figs do we round to? Well, If this has 3 and this has 3, I need 3 here. So it should just be 5.11 cubic centimeters as your volume. All right, so on our next slide, it's all typed up nice without my horrible penmanship. But here we have mass and density given to us, looking for volume, and then we substitute in here, which is the same as volume equals mass over density, and then we solve for our volume and get 5.11 gram, sorry, not grams, just cubic centimeters there, okay? So make sure you try it with your calculator. Can you figure out a way to fix it and check if you're right? Yeah, you can substitute back in. Okay, you can take 13.8 grams and divide it by 5.11 centimeters cubed, and you'll see that you'll get a value of 2.70 grams per cubic